So I'm going to do a couple of examples of using the quadratic formula, one for graphing and the other for just solving an equation. So let's start by putting the quadratic formula onto the magic paper here. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And in this first example where we're going to graph, I'll use a quadratic function like y equals x squared minus 6x plus 9. And if you're looking at this equation and not asked very specifically to use the quadratic formula, you might say, you know, it'd be easier to just factor this, and you'd be right. Chances are I would choose to factor it. It's a pretty straight up perfect square trinomial, but I am not going to do that in this case because I'd like to try using the quadratic formula. So if I'm graphing, I start off just like if I were solving an equation by writing down what the coefficients of a, b, and c are. So a is 1, b is -6, and c is 9. And then I'm going to use the axis of symmetry, which is the first part of the quadratic equation. So my axis of symmetry equation is x equals the opposite of b over 2a. So x equals the opposite of -6 over 2 times 1. The opposite of -6 is +6, and 6 divided by 2 is 3. So the equation of the axis of symmetry is 3. And this gives me two things. It gives me the center of my parabola. It also gives me the x-coordinate of the vertex. So let's go and find the rest of the vertex. And we do that by plugging in 3, the x-coordinate, into the original equation. The original function y equals 3 squared minus 6 times 3 plus 9. This is going to give me the y-coordinate of the vertex. 3 squared is 9. 3 times 6 is 18, so this is minus 18 plus 9, and it looks like the y-coordinate is going to be 0. So the vertex will be located at 3, 0. So I've got a couple of pieces of information that will be very useful for graphing. The center of the parabola, x equals 3, and the vertex, which is 3, 0. I know that my equation is going to be open, or my graph is going to be opening up because my a is positive. So I also know that my vertex is going to be a minimum. I can get some more information from the quadratic formula for graphing. I can also get the intercepts, or the zeros, the places where this graph is going to cross the x-axis. So let's do that next. I want to know how many of those there will be. I want to know whether there'll be 2 or 1, or is it just going to be floating and never cross the x-axis at all. And to do that, I look at the discriminant. So let's find the discriminant next. And remember, the discriminant is the part of the quadratic formula that's under the square root sign. It's the b squared minus 4ac. So I'm still going to plug in the same a, b, and c that we found before, 1, -6, and 9. So b is -6. -6 squared minus 4. A is a positive 1 times 1, and c is a positive 9 times 9. So 6 squared is 36. -6 squared is 36. 4 times 1 times 9 is 36, but I'm subtracting here, so it's minus 36. So the discriminant is 0, and when the discriminant is equal to 0, that means that there's exactly one solution for one x-intercept. This doesn't tell me where it is, it tells me that there's only one of them. To find out exactly where it is, I will need to use the rest of the quadratic formula. So we'll go ahead and plug in the rest of that here. So the opposite of b, x equals the opposite of b, the opposite of a negative 6, plus or minus the square root, and we just found out the b squared minus 4ac up here when we found the discriminant, and we found that was just 0, so we'll plug that in, all over 2 times a, and a is 1, so it's 2 times 1. So minus a negative 6 is just positive 6, plus or minus the square root of 0, which is just plus or minus 0, all over 2. And 6 plus 0 is 6. 6 minus 0 is 6. So we really do only have one solution. 6 divided by 2, or 3. So we're going to have an x-intercept right at 3 on the x-axis. Let's use this information now to make a sketch. First of all, I know that my 1, 2, 3, 4, I know that the center of my parabola is going to go through a vertical line, or be a vertical line through x equals 3. I know that 3, 0 is where my vertex is. And I also know that 3 is the only place that this graph is going to touch the x-axis. So chances are it's going to look something like this. I can be way more specific and use some other information to figure out whether it's going to have a y-intercept, plot a couple more points on either side, but that at least gives me a pretty good sense of the general shape of the graph and where it's located. In the second example, I'm going to use the quadratic formula to just solve an equation. I'm not going to graph it. And the equation, or the function I'm going to use, is 16t squared minus 7t equals 17t minus 9. So I'm not going to graph this. It would be a parabola. I just want to figure out what the heck t is. So I'm going to solve for t. And to do this, I'm going to get all my t terms on the same side, right? So just like I would always solve any kind of equation, move all terms to one side. And because it's a quadratic, I'm actually going to try to move every single term, including the constant term, to one side. So when I do that, I'm going to subtract the 17t from both sides, and I'm also going to add 9 to both sides. And I'll be left with 16t squared. 7 minus 17 is a negative 24t, and then plus 9. All that's on the left, and I've got a 0 on the right. And I could try to factor, I could do all those kinds of things, but I'm going to use the quadratic formula here. So quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And of course, in this case, I'm going to be solving for t, but the a, the b, and the c are exactly what they always are. A is the coefficient of the squared term, so a is 16. B is the coefficient of the linear term, so it's negative 24. And c is the coefficient of the constant term, which means it's just a positive 9. Go ahead and plug that into the quadratic formula. So the opposite, t equals the opposite of b, so a negative 24, plus or minus the square root of negative 24 squared minus 4 times 16 times 9 all over 2 times 16. So I'm going to do a little bit of arithmetic using my calculator and kind of clean it up. Even though I'm not specifically going to find the discriminant, I usually start with what's under the square root sign in terms of cleaning up just in general, because that's usually the messiness or the most complex looking part. So 24 squared is 576, and negative 24 times a negative 4 is also a positive 576. And you can double check that on your calculator. 4 times 16 times 9 is also 576, and I'm subtracting. So it looks like my discriminant is once again going to be 0. 576, take away 576 is going to be 0. And then on the bottom, 2 times 16 is 32. Let's just clean this up a little bit more. Negative negative is 24. Plus or minus the square root of 0 all over 32, which is, of course, just 24 divided by 32. Plus 0 or minus 0 still gives us a 24. And then I'll reduce that. I'll divide top and bottom by 8. And I'll get 3 over 4. 24 divided by 8 is 3. 32 divided by 8 is 4. So the answer, the solution to this problem is t equals 3, 4.